All right, so finally we got that working. Thanks for being patient. All right, so guys, here's the deal though. Like we were just saying, if the goal is to go from some augmented matrix to row echelon form or reduced row echelon form, remember, it's all just fancy talk for we need to get positive ones on the diagonal and zeros underneath. If you can get zeros underneath and above, then that's even better. Okay? But the next obvious question that we've already asked is well, how do you do it? How do I go from looking like this, my original, what I started with, to the desired outcome of that row echelon form or reduced row echelon form? That's where we've got to go. So please don't hear the wrong thing here. Again, I'm going to ask you just mentally to go back to a geometry class when you're writing proofs. Don't hear the wrong thing. We're not writing proofs. We're not doing anything like that. What we're going to be doing does not resemble proof writing whatsoever, but just think back to when you were writing proofs. If you struggled with proof writing, I would anticipate that, and again, I can't say this with much certainty because I wasn't your geometry teacher, but if I were to guess, most people struggle with proof writing at the beginning. Partially because, again, I'm trying to wrap my brain around what it is that we're actually trying to do. But the other thing is that when you first start proofwriting, you have just a ridiculous amount of options as far as what could be reasons. All of the definitions, all of the theorems, all of the postulates, all of that stuff, like those are your potential reasons. And then it seems like as you go on with your proofwriting, it seems like the proofs get a little bit easier. Now, part of that is that you're more comfortable with the format, and you know what a two-column proof is and what you're trying to do and all that fun stuff. But it's also, when you get into like the triangle proofs, you have now a limited number of options. If you're going to prove that two triangles are congruent, it's going to be side, 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 angle, 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 side, hypotenuse, leg. Like you have 5 options, okay? It's been a long time since you probably thought about these, but again, hopefully you're kind of remembering what I'm talking about. So if you think about, if you're trying to prove that this angle is congruent to that angle over there, and you've got a million different options, that's hard to wrap your mind around. If you're trying to prove that this triangle is congruent to that one, and you know in the back of your mind that, all right, it's got to be one of these 5 reasons, that can help drive the proof. Does that make sense? Okay, so kind of using that same logic here, when we're doing our elementary row operations, you only have 3. There's only 3 things that you can do to these matrices. If I have a row and I'm having to adjust the row, it's going to be one of these 3 things that I have to pull off, all right? So the first thing is that we can interchange 2 rows, all right? Now that literally means we take 2 rows and we trade places. So row 1 and row 4 literally trade places. So row 4 is now where row 1 is, row 1 is now where row 4 is, if you did something like that. So the other thing that we have to commit to here is the understanding that if you recall, going back to chapter 7, when we had a 3-variable system and we had to get down to a 2-variable to create our secondary system, we wanted you to do things like this, number 1 plus 4 times number 2 to mark out what we did. Yeah, a lot of us still kind of thought that was optional a little bit. Okay, it is completely not optional here when we're dealing with matrices. All right. Again, the notation has to be marked as far as how did I go from this row to this, or this matrix to this matrix to this one. Okay, so the way that we identify if you're interchanging 2 rows is that we have, again, it's all going to be R with the subscript. So again, this would be row 1 interchanged with, what did I say before, row 4. That's how we would notate. That's how we would write it. Okay, does that make sense? Capital R with the subscript of whatever row it is. Okay, the rows are going to go in order from the top. The top is row 1, then row 2, row 3, row 4. However many rows you have, that's how it's going to look. Okay, our second row operation is that you could multiply a row by a non-zero constant. All right, get a little fancy at the end there. What does that mean? What is a non-zero constant? Something that's not 0, right? Again, sounds a little fancy until you think about it. It's really not fancy at all. All that we're saying is that you could multiply the entire row through by any number you want except for 0. Okay? Third, you could add a multiple of a row to another row. Now, this is the elimination method, is all that it is. So please don't think that this is anything other than elimination. We did this a lot back in chapter 7. We took row 1 plus row 2. Or I just erased it. We had row 1 plus 4 times row 2, things like that. We did it all the time. We're saying that you can do that now with matrices. Okay? So as far as what this would look like, again, going back to the multiplying, all that we would do, all right, yeah, we're going to do 7 times row 2. That's what it would look like. Okay? Adding the multiples of the row, again, maybe we're going to do 5 times row 1 plus row 2, something like that. Guys, what questions do you have on these? Now let's talk for a moment about what we don't see up here. Do you see anything about division? No. Do you see anything about subtraction? No. Not accidental. Okay, that's very intentional, in fact. What we're attempting to do is, of the 4 operations, add, subtract, multiply, and divide, we're trying to cut that down to 2. Now, mathematically, what's the same as dividing by 5? Multiplying by 1/2. So, could we still use this second row operation? And if the task was to turn a 2 into a 1, and we're thinking, yeah, I've got to divide by 2. We just have to not write it that way. We have to, have that part of our brain kick in that says, all right, I'm not dividing by 2, I'm multiplying by 1/2. Okay, are we good with that? All right. Same thing with subtraction. There is no subtraction. We're not going to look at it as, okay, we're going to take row 1 minus row 2. But could we say that we're going to take row 1 plus negative row 2 and mathematically do the same thing? Yeah, absolutely. So again, we want to just, activate your mind to think that everything is going to be in terms of multiplication or addition. Okay, what questions do we have so far? All right, so again, these are the 3 options, the only 3 options. All chapter, every time we're dealing with matrices, these will be the only options that we have. Okay, so it's not like, all right, hey, now that we're in section 8.4, let's show you some more operations. It's not coming. Again, this is it. When we're dealing with matrices, this is the entirety of it. All right, so the goal here is that we want to remain what we call row equivalent. Again, we've got all these little fancy terms and phrases that we want to utilize. All that means is that if you do a whole bunch of row operations, you could do 1, you could do 2, you could do 50. If you do all these row operations, the matrix that you end up with, assuming that you did your math correctly, all of your little calculations were accurate, the final matrix, the final product, is going to be equal to the original, so long as they remain row equivalent. Okay? We call them row equivalent to each other, so long as we did row operations in order to get them. All right, so again, if one matrix can be obtained from the other by a sequence of elementary row operations, they are said to be row equivalent. All right, so once again, this is something that just could show up in the directions. Matrix A is row equivalent to matrix D, or something like that. All right, so we're going to really feel like we're doing some baby steps here on this first one. We're saying that these 2, by the way, what's the order of these matrices? 2 by 3s. Good. 2 rows by 3 columns. All right, so we have a 2 by 3 matrix, and we're saying that that's row equivalent to this next 2 by 3 matrix. Do they look the exact same? Not entirely. Okay. Parts are the same. Would you agree that row 2 is identical to row 2? So that just tells me that we didn't do anything to row 2. Okay. Now, again, hopefully that's an obvious assumption or thing to notice, but it's really important still. Okay, yeah, even if it's obvious, doesn't mean that it lacks importance. That's a big deal that, okay, row 2 stays the same. Row 1's not staying the same. All right, so what we're noticing, excuse me, is that we're going from 3 to 1, 6 to question mark, 8 to 8/3. All right, so as a little bit of a clue, a little bit of a hint, anytime you're changing from a value, any value, to 0, that's going to be the easiest one to work with. The second easiest to work with is if you're going from a value to 1. And the reason why those are easy is because, remember, with our row operations, we're limited in how we got there. So if I'm looking at, all of my focus right now is on, I'm at 3, and I'm going to 1. I'm going to make the argument that in accordance to my row operations, there's only 2 ways that we could get there. What are they? How could I go from 3 mathematically to 1? How could we do that? Subtract 2, I heard Ben say. He said something else, but I didn't quite catch it. Anybody else know what the other option would be? What was that? Or we could multiply by 1/3. Absolutely love the way that Emmy said that. Because it's very tempting to look at that and say, oh yeah, we divide by 3, which is true, but in terms of row operations, we're not dividing, we're multiplying by 1/3. Okay? So, excuse me, just to write this out, we said that we could multiply by 1/3, or we said that we could subtract 2. Right now, if we're only, again, blocking everything else out, we're only looking, how did I get from 3 to 1? Both of these are options. Would you agree? All right, so then now we need to figure out which one of these is actually happening. All right, so now my focus is going to go that I'm going from 6 to question mark. Question mark isn't going to help me out, is it? All right, so we better keep on moving. Now we're going to just look at from 8 to 8/3. Did we subtract 2 to go from 8 to 8/3? No. Did we multiply by 1/3 to go from 8 to 8/3? Absolutely. So now we have figured it out. We figured out exactly what we did to get there. So now how would we write up our row operation? What did we do? Now we targeted row 1, remember, but what did we do to row 1? We multiplied by 1/3. So are we all understanding that this is the answer? First answer. There's 2 answers to this problem. Okay? Now, please also notice where we wrote that. We said that we were adjusting or changing or altering row 1. So we put our row operation on row 1. If we would have written this down in row 2, what does that imply? That we altered row 2. Does that make sense? And since we're altering row 1, that's where we would write it. Okay? Now this one's a little bit different because that was the entirety of the problem, or at least the first part. Okay, now the second part of the problem, we want to figure out what that question mark represents. So now looking back here, knowing exactly what the row operation was, we're starting at 6. Remember, we're just multiplying by 1/3. So what is 6 times 1/3, please? So the question mark is 1. Guys, how do we feel about that first one? Not bad, right? Going back to the beginning, are we all understanding, when we looked, how do I get from 3 to 1, are we understanding that we really only had these 2 options of multiply by 1/3 or subtract 2? Because in all seriousness, if you look at that and you're like, yeah, I've got that, then we're off to a really good start. And that might seem really simple, but again, we're off to a really good start. It's just that as these problems progress, we're going to have to do that with more than just one. We're going to have to do that with more than 1 or 2 of these elements. We're going to have to do that with 9, 12, depending on the size of the order of the matrix. All right? So it's going to get a little bit more complicated here in the 4th example, but again, in your mind, let's keep this straight. We're going to continue on. We know that we only have 3 options. We could interchange the rows, we could multiply through by something other than 0, or we could add combinations of the rows together. Okay? All right, so this time, I like to start with the obvious. What stayed the same? Row 1 stayed the same. We're not touching row 1. That stayed the same. Row 2 has been altered. Okay. Now, could we look at, all right, row 2, I'm changing from -4 to +5. Could we do that? Could we figure that out? Sure. But if we started to create the list like we did last time, of how did I go from 3 to 1, we only had 2 ways to get there. How did I go from -4 to +5? Are we realizing that we have a lot more options? We've got a lot of options as far as how that could have happened. Okay? Like a ridiculous number of options as far as how that could happen. Okay? So if you recall what I was saying before, if you ever see that you're targeting a 0 or a 1, we should start there. So if we're to look at, all right, I am at 3, I'm trying to get to 0. In terms of row operations, how does that happen? The last time we said we multiplied or we added. This time, is multiplication even an option? Could I say, well, 3 times 0 is 0? Well, that's true. What did we say about multiplying an entire row? Multiplied by any number except 0. So that's out. The only way that we can change from a number, any number, to 0 is that we have to add the opposite. Has to happen. So what we are doing is we're figuring out some way to add -3 to this element. That's going to get us to our 0. Does that make sense? That's the first obstacle that we needed to clear, is understand